Okay, this is a copy of the diagram that appears near the beginning of the base article. First of all, let's identify the four regions that correspond to the categories of components that were on the previous slides. The upper left tail of the diagram, which consists of network, computer system, and database structures, is the technical infrastructure category. The lower left tail, which includes information content, system of metadata, and actual indexing, comprises the content and metadata structures category of layers. So the upper left is the technology, the computers, networks, etc., and the lower left is the information itself and the processes that transform that information into input for the information system as metadata. The next category of layers is the retrieval system itself, which corresponds to the big box in the diagram you saw earlier in this lecture, the diagram with the 5 yellow boxes. This category includes everything from information in searchable form up to and including interface design. All of these are parts of the ISAR that deal with the retrieval and the interactions with the user. Finally, the human category are the 2 layers to the very right of the diagram. These are where the user contributes to the ISAR process, user searching activities, and user understanding and motivation. Let's talk about these now in more detail. Like I mentioned previously, I'm not too interested that you learn the inner workings of the technical infrastructure. However, you do need to appreciate that the technology behind the system is an integral part of the system, even if you never see or operate the back end of the system. Don't take it for granted. The content and metadata structures are more important to us here in 670. The information content is the raw material that the ISAR is meant to provide access to. In a library catalog, the information content, which is at the very lower left of the diagram, the information content is the actual books in a library or periodicals or other media. In an archive, it's the actual records that are stored in the archive. The next layer, the system of metadata, is the metadata schema if there is one. And if there's not, it's whatever system or procedure is used in this ISAR for creating surrogate representations of the information content. The actual indexing is how the system of metadata gets implemented. And I really love that Bates separated this out as a separate layer, because really 2 organizations might use the same metadata schema, but the quality or the depth or the goals of how the schema gets filled out might vary from place to place, or even from person to person within one place. So actual indexing takes into account that there can be variance in how systems of metadata get applied. The information in searchable form brings us into the retrieval system itself. This is the layer of the system where we examine whether the information is indexed and transformed into surrogate records is compatible with the types of retrieval operations that will be performed. For example, if metadata records are created to represent a date as a 3-letter month abbreviation, then a 1 or 2-digit day, then a 4-digit year, that's how all of the indexing will format dates and its records. But maybe the search engine is built to process dates in a 2-digit month, 2-digit day, 4-digit year format. If all of the surrogate records are created with data that cannot be processed by the search engine, then the information is not in searchable form, and there needs to be some transformation done to make sure that either the records are changed or the search engine is changed so that these things are compatible. The next layer of the system is the search engine itself, which is the actual algorithm that compares queries with documents and retrieves and ranks documents according to their match with the query. The system front end, this is definitely one of the layers that I de-emphasize because I think it only applies in a few situations. So moving on to search capabilities, these are the query options and techniques that are made available to the user. These don't necessarily have to be buttons or boxes on the interface. For example, Google lets you type special commands into the search bar, like if you type define:"algorithm" into the Google search bar, the top of the results will have actual dictionary definitions for the word algorithm that Google has extracted from several online dictionaries. Or, as recently made the news, you can type bacon number Jimmy Stewart into Google search bar, and it will tell you before it shows you the regular search results that Jimmy Stewart's bacon number is 2 And it will show you the 2 movie hops that need to be made to get from Jimmy Stewart to Kevin Bacon. If you have no idea what I'm talking about with bacon number, you could go ahead and pause the presentation right now and go and Google the phrase bacon number and see what that gets you. It's pretty fun and can be addictive. Anyway, any capability that a system provides to a user to articulate, narrow, filter, or otherwise enhance the search is a search capability. The next layer is the interface design. We won't talk a whole lot about interface design in this course, but it is vitally important to the quality of the interaction for the user and the extent to which the user can get maximum benefit from the system. User searching and activities are the actual behaviors that users engage in, and user understanding and motivations represent the underlying information need, including all of the contextual baggage that comes along, which we discussed back in week 1. So those are all the system, and what Bates does for us here is give us a great understanding by zooming in on the system and looking incrementally at the parts of the system. But we have one more conceptual contribution to thank Bates for in this article, and that is the idea of the cascade of information, of interactions, which we'll discuss next. So the cascade of interactions states that decisions made at one layer can affect performance and quality at any or all subsequent layers. This is a simple statement, but profound. What it means is that you can't just slap together a metadata schema and a search algorithm and assume that they're going to work together. Instead, the metadata schema needs to be designed with a forward eye to the search algorithm that's going to work with it. Or the user interface needs to take into account the searchable form of information by specifying that users should format a date a certain way if they want to narrow their results by date. Now, notice that the impact can only go from left to right. The search engine won't change how actual indexing works, but actual indexing can definitely change how the search engine works. That's why those who are building the earlier layers need to keep in mind what the later layers are going to need. And those who are designing the later layers, the layers to the right, need to be aware of what kind of groundwork the earlier layers have laid for them. Now, the last few pages of the Bates article go through several examples in some depth of how the different layers of an information system can interact. There's an activity on the discussion board that invites you to discuss these interactions, and I'll describe it on the next slide. Now, if you flip toward the last few pages of the bill, you'll see that she describes a series of examples, and they're labeled, you know, example number 1, and there's a name for that example, example number 2, example number 3, and example number 4. Example number 1 is just a very brief one that you can read and understand to sort of get a sense of what she's doing, and then the activity is going to look in more depth at examples number 2, 3, and 4. For this activity, I want you all to use the discussion boards to help each other understand the examples that Bates draws out of interactions among the layers. In order to make sure that all 3 of the more substantive examples get talked through, I assigned you guys 2 examples, as indicated on the slide here. What I want you to do is to go to the Session 5 discussion forum in Blackboard and find the boards for Bates Example 2, Bates Example 3, and Bates Example 4, whichever one you've been assigned to. Read through Bates examples with some care for the one that's assigned to you, and make notes as you read, keeping in mind that you heard and thought about during the lecture so far. For each pair of participants in each example, I want you to summarize and explain the example for your classmates. You can read each other's interpretations to help you grasp the article. That way, not everybody has to comb through each example in great detail. And by getting really in-depth with one example, you can get the idea of what Bates is trying to show, and then by teaching it to your classmates, you can really learn in-depth and then read their summaries to get a somewhat shallower, but still a decent understanding of the other 2 examples. I would like for these discussions to be posted by next Tuesday night so that everyone can benefit from reviewing them before next week's midterm exam. So the next part has to do with ISAR evaluation. How do we know when an ISAR is doing well? What does a good job entail? For this part of the lecture, we are much more system-oriented than we have been thus far, rather than being user-oriented. We're looking strictly at numbers as indicators of performance, which can be a good thing, but which can have some downsides too, as we'll see. Okay, why do we evaluate ISARs? Well, for several reasons as listed here. First, there's periodic assessment of system performance. Any organization that maintains any kind of product or system will undergo periodic evaluation to assure quality control. So that's a very real and common use of ISAR evaluation. Another reason for evaluation is to see how certain aspects of a system are performing, or how a system performs at certain tasks, especially if an organization is thinking about upgrades. They want to prove that upgrades are even warranted. Once system components have been altered or upgraded, then post hoc testing can tell us what kind of performance gains we saw due to the alterations. And lastly, there's competition as a reason to evaluate. Most notably, there's the Text Retrieval Conference, known as TREC, T-R-E-C, which is a competition and conference that's hosted by NIST, the National Institute of Standards and Technology. We'll talk more about TREC in a few minutes, but first, let's get into the performance evaluation metrics themselves.